Welcome to qnawire.
So in this problem, we are supposed to show that the excited state wave function of a hydrogen atom is normalized. So we basically are showing that integration of all space of the probability density function is 1. So to do that, we just uh, square the wave function term, which is just 32 pi r naught cube 2 minus r over r naught whole square e to the power minus r over r naught times 4 pi r square dr. So this 4 pi r square comes because since the wave function is spherically symmetric, and so since the wave function is spherically symmetric, so that means that the angular part integrates to 4 pi, and we have this 4 pi r square, and then r goes from 0 to infinity for integration of all space. In this case, we use the substitution x is equal to r over r naught, which basically gives us r as r naught times x, which means that dr is r naught times dx. So r is 0, x is 0, and when r is infinity, x is infinity. So we basically have 4 pi over 32 pi r naught cube 0 to infinity 2 minus x square e to the power minus x r naught square x square r naught dx. So this term is dr and this term is r square. So we have 1 over 8 0 to infinity 4 minus 4x plus x square times e to the power minus x square dx. So let's move on to the next slide. So we basically have 1 half 0 to infinity x square e to the power minus x dx minus 1 half 0 to infinity x cube e to the power minus x dx plus 1 8 0 to infinity x to the power 4 e to the power minus x dx. Now we use one of the formula given in appendix, which basically tells us that when we have an integration which goes from 0 to infinity for an x variable, given the function of this form, this basically evaluates to n factorial over a to the power n plus 1, a to the power n plus 1. Now for all of these three terms, a is 1 and n for the first case is 2, so it gives us 2 factorial minus 1 half. A is 1 and n is 3, so we have 3 factorial plus 1 eighth. A is 1 and n is 4 factorial. So this basically evaluates to 1 minus 3 plus 3, which gives us 1. So this means that the wave function of the excited state of hydrogen atom is normalized. Thanks.